to another video. In today's video, we are on part 2 of the PC built in a Milwaukee Packout Pro Art Asus. Here is my first prototype, and it's perfect. Getting a little out, and then not perfect, and it's perfect. So where I made my mistake was in choosing to do this in the mirror function. It's not a direct mirror on either side. So when I started it that way, then it just didn't go perfectly. I'm pretty happy with how well it went. Like, I'm amazed at, like, this is just perfect, right? So I am going to actually 100% redo this entire file, because this is the mirror file and it is pretty much locked in to a mirror. Maybe somebody that's super clever, but somebody that's super clever wouldn't be here right now if they use super clever of Fusion 360. I'm fully super clever, but not in Fusion 360 yet. So one of my biggest problems was the fact that I was using a standard SAE measuring tape. Well, that's one of the lessons that I've learned, is doing this type of work in standard measurements is super a bad idea. So I've actually got that exact same tape measure on order, but in metric. So I'm going to go back at this in metric, and that should make my life a lot easier to get measurements from like this point to this point, and then, you know, it's so close, you'd think I'd just be able to do whatever in my previous file, but because it's a mirror, I can't. And there's a lot of mistakes. Like, for instance, these holes, like, I should be able to figure out how to copy and paste these holes, and I didn't. I literally made every single hole by itself. I should be able to cluster these 5 for fans and just copy and paste them and arrange them. I should be able to do that. That's not how I did those. I couldn't figure out how to do that. So I should be able to get this all done in a much more efficient and much more accurate, right? And technically, if I printed this exact thing off, it would fit. If I kind of center it in here, I think there's only one screw that's kind of not there. So technically I could use this, but this is, I see perfection. So if I can nail perfection, I'm gonna nail perfection, right? All right, so I got that. I'll put this back. And as you can see, it's a perfect height. That's where the motherboard goes. I've actually decided to move the GPU. I was going to do like right here, but here's my extender for it, which they folded it in the box and it's got a crease. Not happy with that, but I also have some plugs coming. So the GPU will be up here, and there's 2 GPU DV DisplayPort, excuse me, right? So you got a GPU here, there's a door right here, and the GPU is pulling in the air, and it's shooting out the hot air like this, and up a little bit, right? So then you have the PSU here sucking in air, shooting up here. Well, that situation puts your power and your DisplayPort plugs behind the door, okay? So I've ordered extension plugs for DisplayPort. So my DisplayPort's gonna come over here, and I'll have two places to go in with my DisplayPort for monitors. This is for power. I'm actually gonna move this down someplace. And then the PSU, I will have to open the door to turn it on and off if I want to turn the PSU on and off. But the power is going to come down and go right here. So I've got an extension plug that'll go right here. So I'll be able to have all my I/O right here and make the door, if I need to shut the door, you know, shut it partially, you know, for whatever reason. And whatever reason's typically going to be like forest fire smoke, and I just need to shut it, which if it's really bad, I'll unplug the I/O and shut it. And that's one of the big reasons I'm doing this, is because of dust and smoke in the air, and so I want something that can combat that. So in the thermal dynamics, this bottom is literally curved. So these fans are drawn in with a cover over them. This stuff right here, this magnetic cover kit. So there's little grates right here, right? Or filters. So there's a filter set over that. There's a filter set over the PSU. There's a filter set over the GPU. So intake has got the 4, 5, 6, 7, 8 fans pulling intake. Then the cooler for the CPU, I'm pretty sure I can orientate it any way I want, but it'll be pulling up. So when you look at this from a thermal dynamics standpoint, you've got all the heat being created from the motherboard here being forced up. You got all the heat from the GPU being created here pushing out against nothing. The motherboard's topped out right about here. So the GPU is blowing its hot air out, and because the entire airflow is up, the hot air from the GPU won't be blasting on the motherboard. And likewise, with the PSU, it'll be blowing its hot air straight up, right? So the GPU is here, this hot air is going here, avoiding it by going up here, and then it's all being exhausted out the top, creating positive pressure. So there might be some escapage from the little cracks, air might be, which is what I want. I don't want the reverse of that. So if I didn't orientate the GPU and the PSU to be pulling from the outside of the case, I would have negative pressure because of the screens here are blocking. So there's nothing inhibiting those blowing out. So if it was just 4 versus 4, I would have negative pressure. That's why I'm mounting the PSU the way I'm mounting it and the GPU the way I'm mounting it, to achieve positive pressure to keep this dust free, because I literally, you know, it's a bad problem out here. And I'm showing you here where I cut out a bunch of these little pieces and modified a little bit of the inside of the case here to be able to accept an acrylic faceplate. So there'll still be, I think I'm eliminating a little bit of this 80-20 out of the project, but mostly it's gonna add a ton of strength. So having a one-piece solid acrylic is pretty much where all my strength is gonna come from now. So I've had to learn Fusion 360. I've never used that program before. So, and this is kind of like, if you're wondering, like, why do I need this type of PC? I'm the type of person that can pick up a program and can get her done a little bit, right? Like and subscribe.